going to talk about the next topic that we're going to look at is biomechanics. So we've looked at the motor development chapter. We've looked at the historical foundations. We've looked at demographics, philosophy, and just what is physical education and where we come from, where we headed. So in order to take your philosophy that maybe you started to think about, to take what you know of the history and where we've been, to take what we learned with the motor development chapter, and I know the video on that was not as in-depth as some of the other videos, um, but taking those general concepts, now we want to know how can we actually, when we implement our program, what are we actually going to do? And that is the nuts and bolts of the physical side of the program design, whether that be a coach coming up with a practice plan, a strength coach coming up with a routine for a particular sport, personal trainer with their clients, or a PE teacher designing a PE program. So the idea is we have certain things that we want to look at in certain ways that we want to do that. So the two main exercise science things that we're going to look at past motor development are biomechanics, kinesiology, and exercise physiology. So the first one we're going to look at are kind of the biomechanical factors of physical education, recreation, and sport. So the first thing that we want to do is kind of look at a difference between kinesiology and biomechanics. Kinesiology is really the study of human movement, if we want to look at it that way. And what we're trying to establish there is how to move safely, effectively, and efficiently. And if we can do that, then our athletes or our children that we're teaching in PE will learn better, safer habits earlier on, preventing injuries, and leading to more enjoyment of the activity because they know how to do it properly. And with that comes, generally speaking, improved performance in that particular topic or field of study, whatever that may be. Biomechanics would be more like the application of these principles. So when we're studying it and we're studying how the body moves, we would call that kinesiology. The biomechanics are the actual mechanical factors and how we apply that to the body, or how the body produces these movements. And so that's kind of what we're looking at. What we want to look at is what's the whole point? Why do we even need to look at biomechanics? And again, if we have that more understanding of how the body moves, we can better coach our desired outcomes. So if I know, if I'm teaching someone how to squat, and I'm teaching them, the proper depth on a squat, let's say, and I know what the body can do, and I can see what my athlete is doing or not doing, I can then come up with ways to teach them how to do it. And that would be knowing how the body can adapt to allow their hips to drop a little bit lower, pushing the knees out, opening the hips up a little bit more, whatever the case may be, wherever their deficiency lies. It's not just verbal cues, go lower, go lower, go lower. They may not know, I am going low, how much lower, what do I do? If you can give them some specific cues, that's what we're talking about. So in order to understand what those cues are, again, we have to have an understanding of what biomechanics is, or at least what the biomechanical factors are in relation to movement. We look at it in certain areas. Developmental biomechanics, these are looking at a wide range of patterns and how people have moved and adapted throughout the years, and we can use that for a basis of comparisons when we're doing future studies. Biomechanics of exercise, which is what we're mostly interested in when it comes to designing our phys ed programs and our strength and conditioning programs and things like that. So we want to know with exercise, with running, with lifting, jumping, throwing, what are the movements needed, and then I can train those respective athletes the right way. If I know the proper mechanics of how to throw a ball, I can go back, take a step backwards, and I can teach them the proper ways to strengthen that musculature to get a better throw, faster, harder, more accurate throw, things like that. Training them for what they're going to be doing. Another big one would be rehabilitation. So if we are training rehab for someone with an ACL reconstruction, if I know how the knee is supposed to move, tibial rotation, the knee flexion and extension, things like that, the movements about the knee, I can make sure that their rehab addresses all these issues so that we gain all of our range of motion back properly, but in a safe manner, so we don't go do too much too soon, but we also don't neglect one important factor in our rehab process. And then one of the other big things for someone studying biomechanics or kinesiology, equipment design. And this is cool. This is like this is where you can be an artist and kind of be creative and come up with a cool design that might really impact. So if you know how the body's supposed to move, and you know the natures of the particular sport that the athlete is in, or trying to develop a particular movement, we can design a piece of equipment that will either aid in that or assist, protect, whatever the case may be. I mean, we look at the shoe design. I mean, our shoes have evolved big time over the last 30, 40 years in terms of air pockets and pumps and different kinds of cleats and for different surfaces, and now the minimalist footwear movement, the 5-finger toe things, which are kind of a neat idea, following a thought of, if our foot is designed to be biomechanically our most efficient way, then having a shoe that mimics that closely would give us a better mechanical advantage for running, jumping, lifting, whatever we want to do. And so there's some real truth to that. But again, that's what biomechanics will do. That'll allow us to understand how the body will adapt to these forces and these movements, and if we need equipment or if we can have equipment that will help with that. So it's kind of a big thing. There are different areas of study within biomechanics. Two big terms that come out are kinematics and kinetics. And kinematics would be studying like time and space. Where you are, velocity, acceleration. What your body is doing in movement. The kinetics would be the forces applied to the body, gravity, even your muscular actions. That changes how your body moves. That would be the kinetics versus the kinematics. And so those are two of the areas that we study. Every chapter we've kind of looked at from a research side of things, what are the main research topics, or what are people looking at, and basically what we're looking at is why study this. So we've already kind of talked about the different areas of study, but what are the whys, and what are we looking at, and do runners have poor form, and is that causing them to have a particular overuse injury? We're looking at it from that angle. How do some of the forces that we use, say in weightlifting, how do we activate and innervate different muscle fibers enough to lift a particular weight? And that would definitely fall into that range of study of movement. how we know how to generate enough force, but not too much, and how we can control that to increase force production in weightlifting. And there's we can go on and on about different topics here in terms of what we're looking at. So the next thing I want to do is look at, sorry, my computer's a little iffy here today. What we want to look at is some terms. And so the terms that we're going to look at here are just a few of some biomechanical terms that we look, or that we'll discuss, or that might come up in other chapters when we go to start addressing program design and things like that. So the first one is velocity, and that would be the speed and direction of the object or of the body. The acceleration, which is change in velocity. We have what's next here? Angular velocity and angular acceleration. So angular velocity would be the velocity about a certain range of motion, so moving through a certain motion, kind of rotated around an axis. And angular acceleration would then just simply be the change in velocity, again, around that range of motion. Mass is the amount of matter possessed or taken up by an object. Force is an action that changes or tends to change the motion of an object. So, we'll talk later about Newton's laws and how that relates to motion. Pressure is the ratio to the ratio of force spread over a certain area that the force is being applied to. So we'll talk about force production when we're lifting the bar off the ground, or when we take off in a 100-meter sprint. And the force pressed against the ground gives us an equal and opposite reaction. Again, we'll talk about Newton's laws here in just a minute. Gravity, our natural force that pulls the object towards the earth. And we have work, which is force applied to the body through distance, or over a certain distance. So for example, if I have 100 pounds on a bench press, and my arm length is 2 feet long, and I go and I do my bench press over 2 feet, that 100 pounds times the 2 feet will give us the amount of work that I just did. Therefore, someone with a shorter arm length will do less work with the same amount of weight. They have a 1.5 feet they press 100 pounds through. They just did more work. That doesn't necessarily mean that they're stronger, or that I'm stronger because I did more work. It just means that they didn't have to use as much force or as much energy, total energy usage, to complete the same movement. And again, we'll talk more about levers and those biomechanical factors in just a little bit. So hang tight on that one. Energy is just the capacity to perform work. So that can be kinetic energy or potential energy, and again, that'll lend itself here in just a minute to a further discussion. And torque, which is the applied force that would change angular acceleration. So you got a wrench and you're cranking it around to tighten a bolt or loosen a bolt. That's torque. I'm applying that force, increasing the angular acceleration around the bolt or the axis, and that's torque. So I'm going to stop there on this video, and we're going to pick it up with part 2.